Hi guys, welcome back. Thanks so much for being here. We got about 1 minute until it's the official class time, so let me just get myself a quick little beverage. I'll be right back. Okay.
Nice to see you guys in here.
Okay. Hi guys, welcome back. Hi Stephanie, Rachel, Jamie, Nathaniel, and all the rest. You guys are doing good. So it's pretty much now 11:30. That means let's get our class underway. We've reached the last week of the regular semester, and next week is finals week, as you guys know. So we're down to the last thing, which is the final exam. This week, all I want to do is go over the whole class and just review major concepts so that you guys have a good sense of how to do well on your final. And hello, everybody that's saying hi. I see you guys. April, Valeria, Melanie, John, Reb, Jessica, and Marissa, and all the rest. So let's see. Did any of you guys notice the study guide that I mailed out on, what was it, Friday or Saturday? Let me know if you got it so that I can make sure there's been no issues with the delivery of that. Let's see what you're telling me here in the chat. Got the study guide? Okay, good. So that study guide basically shows the list of major topics that we're going to cover. Some of the information on the study guide has to do with topics that were in the first half of the semester, and then, you know, most of the second half of the semester has all really been about derivations. So, so to add to the material that we're going to review from the first half, we'll just kind of brush up on our ability to do these derivations again too. So to get things started, I guess, I'll go through the study guide and the items that are there. And what I like to do with review sessions, and this has just always been my method, is to have the students take a little bit more of a lead. So Valeria, when did you send me that email? Was it this morning? The reason I'm asking is because I think I've given confirmation to all of the messages received as of yesterday. Frida, check your inbox. I believe I've just now given you your confirmation. The ones that I've received after midnight tonight, or after midnight last night, I still have to go through the queue. So I'm continuing to go through my inbox to confirm all the received homework submissions. I have other classes as well. Yeah, so if you sent it at 11:13, do not worry, you're going to get your confirmation. Right after class, I'm going to continue going through and delivering all the responses to everybody. Yeah, so to those that have mailed it through the weekend, they've received their confirmation. Anybody that sent it as of today, I just have to get to you guys during my office hours, which they're going to closely follow after the end of this class period. So don't worry, you're going to receive your confirmation if you sent me the message. If you do not get a response by today, if you had sent something, that would be the case where you should be concerned that there was a problem with the delivery. But for now, there's no issues. So thanks for your question, but don't worry. Okay. Anything else? I always want to make sure that if you have questions or thoughts on mind, that I can help clarify it. So I'm glad that you asked that. If anyone else has any questions of any type, whether it's about the course, the material, or anything in between, just do let me know. We're all clear on the time and date of the exam itself, right? I'm looking at the syllabus here. So it's making sure I'm giving you the proper time and date. So it's that's Wednesday, December the 16th from 11 a.m. until 12:50 p.m. So that's the time slot for our final, just so that everyone knows to make that clear in your calendar of dates. Not to worry, Jamie, I'm sure that I will receive your message, whether there's a subject there or not. I don't delete anything. That's a huge inbox with just no messages ever deleted. So if it's there, it's there. that's just our time slot. It's a week from Wednesday. So today it's the 7th. This is 9 days from now. So we have today's meeting, Wednesday's meeting, 2 review sessions, and then a week from then. Will there be any more extra credit opportunities or any extra credit questions on the final? Yes, I would like to provide an opportunity for some extra credit. I'm thinking through what the best option is for that. One thing that I was considering is simply to award like 5 or so points, maybe 10. I've been making that choice, but award some points for just having students do a grade check with me. And then that will accomplish 2 things at once. You'll get some extra credit, you'll know your grade, and then that'll give you an incentive to ask for it. And then I might also include, as you're asking, like 1 bonus question on the final that will help to boost the score a little bit more. So yeah, I have a plan to do that. So thanks for your question, but stand by and I'll notify you guys during this week what the official option is. Okay, so we're all good then for the moment. We know the time and date of the final. I guess now I want us to consider the topics that are on our study guide. So first thing I'll do is let me pull up this Zoom meeting, and then we can do the dual platform thing so that we can all focus on the study guide together. So give me a second while I copy and paste the link. Okay, so there's this link. Go ahead and go to the meeting. I'll be right there. Okay, I see we've got some participants in the meeting. Thank you guys. I'm gonna share the screen. Okay. And let's see, where did I put this study guide? There it is. Okay.
Okay, so let's get started. So last class we
Let me expand this a little bit. Sorry.
Today we're going to move on and we're going to talk about.
Okay. Cool. So here we go. This is our study guide. Let's make sure to just talk about each of the different topics that are on the list, and I'd like to get you guys to give me your contribution. So hold on. Just to double check on our chat. Anyone want to type something here in our Zoom so I can see that everything's clear and you can hear me? Okay, hi Jamie, good. All right, perfect, thanks Brenna, you too. So let's just go down the list, and when we see something that needs clarification or more explanation, I'll try to kick in and help, but I want you guys to do the most you can on your own, but I'm here to help. So anyway, yeah, let's start with the beginning. All these definitions and concepts are things that we've learned in our class, that are in our book, so let's try and bring it back into the forefront of our mind. What is an argument in the formal sense? Okay, Frida, you say it's 1 or more premises and a conclusion. Good. That's one good way to put it. I think that in our book it says something which is basically equal to that it is a set of how many sentences? An argument is a set of blank or more sentences. 2 or more, correct, Frida. So it's a set of 2 or more sentences where one of the sentences is designated as the conclusion, and all the other sentences are premises. Okay, a little bit more. So that's the basic definition of an argument. The conclusion of the argument is the statement that you are trying to do what? The conclusion, what is its role? It's the part of the argument that you're trying to show or prove to be what? The conclusion of the argument, the bottom statement. This is the statement that you are trying to what? You've said these words, premises and conclusion, but I want to have an explanation of what those 2 things are. The conclusion is a statement that you're trying to what? The whole point of making an argument is to what about the conclusion? Prove it, yes, that it's true. Let's not forget that, guys. This is not just random stuff we're doing. We're trying to prove things with these arguments. So the conclusion of the argument is the sentence that you're trying to prove to be true. The premises are what? The premises serve what role towards the conclusion? So the conclusion is what you're trying to prove. The premises are the sentences that what? They're the reasons or the evidence that support the conclusion, correct. So the premises give the reasons that support the conclusion. The conclusion is the statement that's supposed to be proven true based on those premises. Okay. Next, what is a deductively valid argument? Let's focus on that before we go to the example part. Correct, Valeria. It is not possible for all the premises to be true and the conclusion false. That's what it means for a deductively valid argument to exist. It is an argument where if the premises are all true, then the conclusion cannot be false. So basically, yes, it's impossible for it to have all true premises and a false conclusion. What is like a random example of a valid argument? Let's see you come up with just an example. Like what? One way, a valid argument generator that's pretty easy to use is just say some statement that says all of something has a certain feature. And then you can continue through the logic of the argument until you get, okay, so Frida, all humans have been on Mars, right? Obama is a human, second premise. So therefore Obama has been on Mars, correct. That is a valid argument. It's valid because if those two premises are true, the conclusion can't be false because of what the premises say. So assuming the truth of the premises, the conclusion has to also be true. But this example is not sound, so that takes us to our next question. What is a sound argument? What is a sound argument? We need to know what this word sound means. What is a sound argument? Correct. It's a deductively valid argument where all the premises are true. So it's like the format of the example you just gave, Frida, except it would have to be a case where the premises are all true. In the case you gave, it's not sound, even though it's valid, because as you all know, the first premise is not true. But what is a case where there is a valid argument with all true premises? So a sound argument. Let's hear one from somebody. So go ahead, everybody. Take the initiative, do your part, and just give me an example of a sound argument. Just an argument, you know, a couple statements that lead to a conclusion. But in this case, the premises have to be real. They have to be like real, corresponding to the reality. So what's a better example? Well, I mean, the first example is good, but what is an example of a sound argument? Okay, Lily, all humans are mammals. Joe Biden is a human, and therefore Joe Biden is a mammal. That's a fair example, sure. Because it's true that all humans are mammals. That's just the classification of what kind of species that we are. So take one example of a member of the category human, and since all humans are mammals, that human is also going to be a mammal. So this is a valid argument, which is sound. Okay, great. So let's go on. Well, what would be a valid argument that's not sound? We already, I guess, gave one such example above by Frida. Who else can give me an example that is similar in style to Frida's, but just with different information? So I'm asking for a different case of a valid argument, but which is not sound. Another example which has a similar structure, but uses different premises and conclusion. So go ahead. Valid, but not sound. It just has to be like the conclusion follows from the premises, but these premises are not actually true. So what would be another case? Okay, so you say, Brenna, Dr. Vulich has been to the moon. That's one. Oh, sorry, I see the whole argument now. Thanks, that's a conclusion. Okay, all professors have been to the moon. Dr. Vulich is a professor, so Dr. Vulich has been to the moon. Okay, so I guess when you guys go into like valid but not sound, a popular type of example is mentioning that all people have been to like a planet that, of course, no human being has ever been to or whatever, or a place that most all of us have not been to. So fair enough, good. Yeah, all professors have been to the moon. I'm a professor, so it would follow logically that I've been to the moon, but of course that's not sound because of premise one. Okay, so then let's go on. What does a valid argument that is not sound have in common with a valid argument that is sound? Okay, so now that's a question that you can consider by looking at the examples above. Look at Lily's example, which is sound. Look at Brenda's example, which is not sound. Both of them are valid. So what is the thing that's in common with these two? You know, they're one sound and one isn't. But what does it mean to say they're both valid? It just means that in each of those two cases, what? The conclusion logically follows from the premises, yes, and deductive reasoning leads you to the conclusion from the premises. So in both cases, there's a logical link between what the conclusion says and what the information in the premises says. So they're both like logically connected, but in only one case are the premises facts. Okay, so then induction. We haven't done too much throughout our semester with induction. We kind of talked about it in the beginning and left it behind because this is a class that's mostly focused on deduction and deductive arguments. But I don't want us to forget it. So let's just quickly ask, what is an inductively strong argument? It's not deductively valid, inductively strong. What does this mean? Okay, good. So if all the premises are true, then the conclusion is likely to be true. It's highly likely, but unlike with validity, it's not guaranteed. So let's hit me with an example, somebody, of a inductively strong argument. It's not valid, but the conclusion is probable, assuming these premises. So what could be something along those lines? The sun has come up every day. For how long though, Frida? For a week, for 3 days, for a month? It matters to mention the duration of time because that will enhance the feeling that the conclusion is very strong. For many years, they're still kind of, I feel like, lowballing it. I mean, we're talking about the sun here. It's not just, I mean, I've been alive for many years, but the sun has been around for so much longer. So anyway, I would say it's billions of years. It's billions, okay? But anyway, go ahead. So the sun has come up for billions of years, whatever, and therefore what? That it will come up tomorrow, correct. Okay, so it probably will come up tomorrow. I think that we're all pretty well, you know, convinced that that's likely and that's probable, but it can't be absolutely guaranteed even on the basis of a long-standing pattern in the past. So I don't know, every day I've had something to drink for my entire life, so today I'll have something to drink. My car has never stalled on the freeway, and so I've driven for 10 years, and so therefore it won't stall today. I don't know, just giving examples perhaps that a person could use. So keep that in mind. I want you to have an example of an inductively strong argument and to know the definition of it. It's possible that I could select a question about that, but it would be an easy question, so that's one that you should keep in mind. Okay, so next, what are the two truth values? Okay, true and false. Truth and falsehood. Give me an example of one sentence that's true and another sentence that is not true but is instead false. So this should be one of the easiest things. Say something true. Okay, you say 2 + 2 is 4. I always find it interesting though that when I ask people for an example of a true statement, a lot of times we go to math. Fair enough, math, but like, how about something that has nothing to do with math, like something about the world? Okay, what's something true? 2 + 2 is logically true. How about something that's just regular true? Are we really having trouble with this? Come on, there's infinite enough. Look around you, there's true stuff everywhere. So just tell me something true. The earth is round. Okay, good. Snakes are reptiles, also good. That's, again, it's kind of a classification thing though. How about a fact? I mean, the earth is round, that's a good one, that's a fact. But I want you guys to kind of get in the habit of being able to say these a little faster and more just random stuff. So just tell me something true. I'm a professor. Okay, cool. How about something that has nothing to do with me? Water's made out of hydrogen and oxygen. True. How about something about history, guys? What about history? You guys are like, there's no world facts about like people. Give me something about history. Something about world history. Obama was president? Yeah, he was. Okay, good. And that's pretty recent. Gandhi was assassinated. True. Okay, fine. Thanks. That's just examples. I wanted to give a variety of examples so that you get a sense of like what are true things. What about some false stuff? Tell me something false. Something false, something that is not true. Some false sentences. Boston Tea Party occurred this year. Okay, that's not true. So very good. That's false. Something else? Hillary Clinton is president in 2000. Yep, that's not true. That's false. It was, well, it's actually Clinton all throughout 2000. And then 2001, Bush took over when he was inaugurated in January. Good. So here's something interesting too. The negation of anything true is false. So if I say it is not the case that Obama was president, that's false because it's the denial of something true. And the denial of anything false is true. So if I say it is not the case that Hillary Clinton was president in 2000, that's true because that's the negation of a false statement. Okay, anyway, good. So let's continue. How about an argument that's invalid, but all the premises are true? Let's see you give me something like that. So produce an argument, give an argument, make sure that every premise is a fact, but make it that the argument is not valid. So you basically have to have an argument where the conclusion is not guaranteed by the premises, but the premises are actually true. Pretty easy in a way to do this because you just, if you come up with a conclusion that's totally unrelated to the premises, that's going to be invalid. So, you know, think of like some facts that you can use as premises and then state a conclusion that has nothing to do with those facts. Or even a conclusion that's false. I mean, that would be another fine example. So if you have like true premises and a false conclusion, that's automatically invalid. But yeah, go ahead, let me know. Let's go, come on, speed. Argument, premises all true, but it's not valid. Invalid argument is easier to think of than valid. Valid, you have to be like, okay, well, what do these things imply? With invalid, I mean, yeah, okay, so we're in the middle of a pandemic. True. California, Fullerton is in California. Cal State Fullerton's in California. Okay, that's also true. So those are decent. And so, therefore, the Lakers won the NBA Finals. Okay, that's good. That's not a valid argument, even though every statement there is true. Because after all, look at the conclusion. It says Lakers won the finals, but did the Lakers winning the finals, was that somehow guaranteed by the fact that there's a pandemic happening and that Fullerton is located in California? No. Fullerton being in California and us having a pandemic still would have been true if the Lakers had lost at any stage during the playoffs. So those premises, though they are true, they don't guarantee that the conclusion is true. Valeria, you say Trump is older than 35 and therefore he's the president. Yeah, that's not valid, good, and the premise is true. Even though the premise and the conclusion are true, the premise does not guarantee the truth of the conclusion. So being older than 35 is sufficient. Sorry, it's necessary for being president, but it's not sufficient. So just because he's older than 35, that does not logically guarantee that he becomes president, even though he happened to do so. Okay, good examples. So now let's go to the next. What does it mean for a sentence to be logically true? Okay, good. So when it cannot possibly be false. So it's got to be a sentence that is true, and it is not possible for the sentence to be false. So what's an example of such a statement or sentence? Logically true sentence. I want to make sure this is clear. What's an example of a logically true sentence? Okay, 2 + 2 is 4. That's a good example, right? Because 2 + 2 being 4 is true no matter what. It's not like just true if something. It's not just true like, so like Trump is the president, but only if, you know, he wins an election. But 2 + 2 is 4 is true no matter what the case is. So that's like logically true. Other examples could be anything from math or from geometry. A triangle does have 3 sides, and that's not like capable of being false. It's not possible to say sometimes it has 4, sometimes it doesn't have 3. No, necessarily a triangle does have 3 sides, so that's logically true. It's necessarily true. Okay, so wait, question. Human beings breathe oxygen. Is that logically true or no? Is that true or is it not? Or sorry, is that logically true or not? Well, it's true, but I'm asking a question. Is it logically true? Humans breathe oxygen. Correct. It's not logically true. It is not logically true. Because although we breathe oxygen, it's like science fiction possible to imagine, like, I don't know, we build technology that allows us to live without breathing, and somehow we just get oxygen infused directly into our bloodstream through like a pump. You know, it's possible. It's like, it doesn't have to be likely. It just has to be like even something that's theoretically conceivable. I've seen people give examples like all humans have a brain is like logically true, but that's not even like true in the world, because there's encephalitic births where people are born with a crazy birth defect and they don't have a brain. I've heard students give the example, every human being has a heart. That's not even true. There have been extremely rare cases where a person had a heart transplant and they had like a robotic heart pumping blood for them instead of having an actual heart valve. So when you say logically true, use math. Do not use anything that seems like, oh, this is so obvious because it's about the world and everyone knows that we all breathe the oxygen, or that, you know, the fish are in water. Fish are not all in water. There's a mud skipper that sometimes is on land. So, I mean, I'll come up, you know, even if it's possible for there to be a counterexample, it's not logically true. Okay, so now logically false. What does that mean? Cannot possibly be true, correct. What would be an example of a sentence of that kind? Logically false now. Something that's, it's not even possible for this to be a true thing. Something like what? Logically false. Okay, 1 + 1 = 9, correct. So a false mathematical formula or equation or geometric statement would all be logically false. You can also derive logically false statements of Brenna. So look, again, this is the same thing I was trying to correct before. That is not logically false. The Earth could be the closest planet to the sun. It's possible. It is not, in fact, but if the world of the universe had developed differently, then it could have been that way. Or suppose tomorrow that like some passing asteroid of a massive size completely obliterates Venus, and what's the second one? We're the third, so it's, I know, Mercury, is it? Venus, and then us? Whatever. Suppose that a huge asteroid or whatever from passing by in space destroys those 2 planets, and then we would be the closest planet to the sun. Since that's possible to imagine, what you're saying is not logically false. Logically false has to be, I can't even contemplate a possibility where that could occur. And so have you maybe not been creative enough? Think about it. The planet Earth, we are the 3rd planet from the sun, but not only is that not necessarily true in all possible circumstances, but the sun itself will eventually explode. I mean, this is not a permanent arrangement that we have here. It's a finite time. So when the sun explodes, there won't be any planets close to it because it won't even exist. So what you're saying is true, sorry, is false, but it's not logically false. Okay, so the stuff with math, geometry. Now I was going to give one more example. If you make a statement where you contradict the predicate, like if you say the brown dog is not brown, that's logically false, because it's like saying A is not equal to A for some A, and that's a straight up contradiction. Okay, so let's go on then. Definition and example of logically indeterminate. So what is a logically indeterminate sentence? That's just a sentence that's what? A sentence that is neither logically true nor logically false, something that can be either true or false, correct. So we've already used a few examples like this, but let's just throw out another one. Something that could be true or false, but it just depends. Like what? Okay, you're saying you're wearing a hat. Now, I have no way to know without a camera whether that's true or not, but it doesn't matter because it's something that could be true or it could be false. Hillary is president, correct. Yeah, that's false, but it could have been true. It's sunny. Where I'm at in Long Beach right now, it's actually cloudy, but fair enough. Anything about the weather is going to be contingent on the circumstances of the weather, and it's not necessarily true or false. Okay, very good. So next up then, let's go with, yeah, so it says here, definition example, pairs of sentences that are logically equivalent. So for 2 sentences, a pair of them to be logically equivalent, what does this have to mean? If they're equivalent, then this means what about the 2? two sentences are equivalent. So, in other words, this means that for those two sentences, it is not possible for one to be true while the other one is false. Exactly. So if you have two sentences that are equal, then that means they have to have the same truth value. They have to have the same truth value. It cannot be a case where you could consider even mentally one of them is true and the other is false. So they have to have the same status, same truth value in all possible worlds. Can you tell me two sentences like that are equal? They're two sentences, but they're equal logically. So like what? You see the definition, and that's important, but then we have to state an example. So let's give one. Two sentences that are equivalent. I'll see what you come up with, and if you need a little help, then I can work with you. Okay, so yeah, Brandon, Bill is older than Joe. Joe is younger than Bill. Yes, correct, because those two sentences say the same exact thing. Bill being older than Joe means the same as Joe being younger than Bill. So suppose that the left sentence is true. Suppose that it's a fact that someone named Bill is older than someone else whose name is Joe. If that's a fact, then the other statement also has to be a true fact. It can't be that, well, Bill is older than Joe, but no, Joe is not younger than Bill. That's impossible. So those two things are equivalent. So with relations that are like asymmetric, like older than, we can always generate an example like this. Or another case would be, I don't know, taller than. I'm taller than Kevin Hart. Kevin Hart is shorter than me. Those two sentences are logically equivalent. Now, when two sentences are not equivalent, that means that they can have different truth values. Okay, so how about this? Romeo loves Juliet, Juliet loves Romeo. Are those two sentences equivalent? No, they're not? Good. Why not? They're not equivalent, correct. Why not? Why aren't they the same? You just need to tell me. Love is not always reciprocated. So is it possible for Romeo to love Juliet? I'm using these names from literature, so I don't want you to be thrown off. It could just be someone else, Jack and Jill. If Jack loves Jill, that's perhaps then true, but it doesn't mean that Jill has to love Jack back, or the Romeo and Juliet case. So love can be one-sided and not returned. So yeah. Now if I say, here, another example, Romeo loves Juliet, Juliet is loved by Romeo. Are those equivalent? Romeo loves Juliet, Juliet is loved by, yes. Because to say she's loved by is just a fancier perhaps way of saying that she's receiving love from him. And we could say he's directing love toward her, or that she's receiving love from him, but that's the same thing. If he's showing her love, then she's being shown love. And so there's no way for those two things to have different truth values. Okay, good. So let's go then to the next. When a set of sentences is logically consistent, what does that mean about the set? A set of sentences that is logically consistent means what? What do you say? Talking about consistency here. What is this? Consistent, just in case it is possible for all of them to be true. Right. So that means that they may not all actually, in fact, be true. But if it's possible for them to all be true, like even hypothetically, then that set of sentences is consistent. When it's inconsistent, that means that they cannot all be true. So they contradict each other in some sense or some way. So let's think. What about this set of sentences? Professor Vulich lives in Long Beach. Hillary Clinton won the 2016 election. And the COVID-19 pandemic never happened. So are those sentences consistent? I said, Hillary won the election, there was no pandemic, and I live in Long Beach. Yeah, they're consistent. Those are consistent because it's possible to imagine a scenario where they were all true. One of them, me being in Long Beach, well, that's a fact in the actual world. The other two sentences, that there's no pandemic and that Hillary won, those are not actually true, but it's not inconceivable. It's not like outside of the realm of like imagination that those things could have all been true. And that's what it means that they are consistent, if you can imagine them all being true, even just possibly. But what's inconsistent is like, I don't know, Dr. Vulich lives in Long Beach. Dr. Vulich is older than Barack Obama, and Barack Obama is older than Dr. Vulich. Because I added those second two statements, which contradict each other, they cannot all be true. And that means that that's an inconsistent set of statements. Like here's another case. I don't know, somebody says there's no pandemic, and then they also say hydroxychloroquine is the best way to treat the coronavirus. Those things are not consistent because one says there is no such thing as the coronavirus. The other one says there's this weird alternative treatment that helps to prevent you from getting sick from it. Those things can't both be true because if there's no such virus, then there's no such thing as a treatment for the non-existent virus. But if there is a treatment for the virus, then of course it exists. But sometimes people have confusion and contradiction in their own thoughts. They say two different things, and maybe sometimes they don't even realize that these things are not compatible. Well, when we have sets of sentences like that, then they're inconsistent. Okay. Like, I don't know, here's another case. I had the biggest graduation ever. There were 100 people at my graduation, and there were 1,000 people at my brother's graduation. Those sentences are not consistent. Why not? Just let's see if you can figure that one out. I said, I had the biggest graduation of all time. There were 100 people at mine, and there were 1,000 people at my brother's, at my little brother's. So are those things consistent? Yeah, my brother had the bigger graduation because of the way numbers work. So one number is 1,000, one number is 100. But then I said I had the biggest graduation of all time. So these three statements, they can't all be true. If I did have the biggest graduation, then I can't have a number that's smaller than the number of another person, etc. Okay, so let's go down to the next. So how to translate English sentences into the language of SL using a symbolization key, sentence letters, and the 5 logical connectives. So we spent considerable time doing symbolization and translation. What if I want to translate this? Here's a sentence written in English. I want us to just translate it into logic. So to do that, we have to designate some sentence letters in a symbol key. So go ahead and just get to work telling me what symbols I might want to use here. C, I have COVID. Okay, good. But that's not all. S, I'm showing symptoms of COVID. Okay, so we got our letters, and then we just have to use those with our symbols to translate that. So good, Frida. It's just C and not S. Okay, have COVID, C, and but is a logical equivalent of a conjunction word. Have COVID, but not the case that I'm showing symptoms. Not is the tilde sign. And that's why we prefix it to the letter S to show not the case, negation of S. S is that I am showing symptoms. This says that I'm not. So two things, both I have COVID and also not showing symptoms. Okay. So here, let's try another one since we're going to try and do a little review on these translations. If I get COVID, then let's see, I want to say like two things. Okay, if I get COVID, then either I will recover quickly or need to go to the hospital. So If I get COVID, I'll either recover quickly or I'll go to the hospital. So let's get some letters for that. I figure I know perhaps what you might use, but I want you to do it. See, well, you wouldn't say the word if, to be clear, Valerie. You would just say I get COVID, because the word if is symbolized with the arrow or the horseshoe, so we don't actually have to put it in the key. C, I get COVID. Okay, not to worry. And then R, I will recover. Okay, and then H, I will go to the hospital. Okay, so there we go. Now translate that. If I get COVID, then in that case, I will either recover quickly or I will go to the hospital. So we have to have good Frida. C, arrow, parenthesis, the disjunction of R or H. Okay, good. How about this? If I don't recover, if I get COVID and I don't recover, then I will go to the hospital. You heard me? If I get COVID and I don't recover, then I will go to the hospital. If I get the COVID and do not recover, then in this case, I will go to the hospital. What's that one? If get COVID and not recover, then hospital. What's this? Using the same letters. No need to create new letters. I'm just using the same symbols to establish another logical translation.
And it's exactly what Tanner states, right? The whole concept of trust.
Okay, Arlene, if C and not R, then H. Yeah, in this case, the antecedent is a conjunction, and the conjunction includes that I get COVID and I didn't recover. How about just simply if I get COVID and I won't go to the hospital? If I get COVID, I'm not going to the hospital. What would that be? C, then not H. Good. If I don't wear a mask, then I'll get COVID-19. If mask is letter M, then that would be tilde M, arrow C. Anyway, just giving you some different examples quickly as we remember that we're doing translations too. Okay, sometimes there's bi-conditionals. That would be like the statement if and only if, or just in case. If I say I'll get COVID just in case I don't wear a mask, that would be C, double arrow, tilde M, if M stands for that I wear a mask and C stands for that I get COVID. So I'll get COVID if and only if I don't wear a mask. So there's conditionals, there's contracts, disjunctions, negations, and bi-conditionals. Okay, so translating arguments into SL. So when you have an argument, you just have to remember that if you're looking at it in English, you have to first understand what is the conclusion of the argument and what are the premises. When you look for the conclusion, you'll have to look for a conclusion indicator word, and that will show you in the written passage where the conclusion is. What are some examples of these so-called conclusion indicator words? Words that point out that we're now seeing a conclusion of an argument. They're words like what? Just let me know a couple of the famous conclusion indicator words. Words that you say before you state the conclusion. So like, therefore, good, that's a very well-known one. I see a private question, a student asking, will we have to come up with examples? No, you will not. But knowing how the examples could be generated helps you to understand the concept. So don't worry that I'll have to, I won't ask you to be like coming up with your own arguments and stuff. But back to the question, therefore, yeah, therefore, thus, there's also a couple more. So I don't want us to only, not furthermore, no, Samir, that's not a conclusion indicator word, because that just means that's actually a conjunction word. If I say I'm sick, furthermore, I'm miserable, that would be like S and M. It wouldn't be an implication. So there's it follows that. There's in conclusion. There's just the word so. I don't want us to forget that because that's one of the not resulting actually, no, Brenda. So there's therefore, thus, it follows that, ergo, and just the word so. So is very common, and so remember that because it's often used in many of these passages that you see that you have to translate. Okay, so anyway, when you translate the argument, you have to place the statements in listed order with all the premises above a horizontal line, and then the conclusion will fall beneath that horizontal line. There's only one conclusion for each argument, so you just have to find what the conclusion is, put it at the bottom, and then state the premises above it in like a list fashion. Okay, so then truth tables. When we make truth tables, we have the ability to test sentences to see what their logical status is, to see whether they're logically true, logically false, or logically indeterminate. So, like for example, let's see here. Here's a big sentence, and I want to create a truth table for it. So when we create a truth table, we place the sentence or sentences to be analyzed in the top right quadrant of this cross structure. And then what goes here on the top left? In this space here, what should be there? The letters A, B, correct, because it should show the sentence letters that are used in the full sentence in the alphabetical order that they occur in. We have to place a downward-facing arrow above the main connective of this sentence here. In this case, where will our down arrow be placed in relationship to that big sentence? It goes above the main connective. Well, there's a set of different conjunction symbols, Lily. Which of them is it that you're talking about? The second one, this one. Okay, good. Correct. Just look at what is grouped by the conjunction symbol to determine where the main connective is. It could not have been this one because this conjunction symbol just joins these two things together, but not the whole formula. It couldn't be this one either because this only joins these two sentence letters together, but has nothing to do with the left side. But when you look at this conjunction sign, the left component is this whole formula. The right component is that whole formula, so it's the main connective because it joins the whole thing together. So we have a downward arrow over that. How many columns, or sorry, rows do I need in this truth table? I do need 4, because if you remember, there has to be how many rows? Well, for the addition of each new sentence letter, you multiply by 2 the total number of rows, starting with a case where there's 2 rows. So when there's 1 sentence letter, there's just TF. When there's 2, you need 4 rows to display all the combinations. And if there are 3 sentence letters, we expand the truth table to 8, and so on. Okay, so underneath A, we have to have a series of T's and F's placed vertically going down. What's the order, if you remember, underneath A, in terms of T's and F's? It's 2 T's, 2 F's, correct. Now as we slide to the next column, we have to do the same under B, but the ordering is now what? TF, TF, correct. So then, to complete the table, we simply now go and place the truth value assignment that we see in every horizontal row, and we award it the truth value that is given in that row. So in this top row, A and B both get the letter T. In the second row, A receives T and B receives F. In the third row, A receives F and B receives T. And then here in the fourth row, they both receive the truth value of false, F. I did it in this case horizontally left to right by looking at this assignment and then filling in the appropriate corresponding values. You can also do it vertically down if you like. Then you would simply look at A and match to the display shown here on the left, namely 2 by 2, and likewise with B. But anyway, so we've got the A and B sentence letters filled in. Now let's go ahead and designate the truth value of this conjunction in these 4 empty spaces. So blank, 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 4 truth values. Who could tell me, if you know, what those 4 letters will be? starting at the top and then going down through the series of 4. It's T followed by 3 Fs. Yes. Okay. Now to this side. Again, what's this column going to be? Blank, 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 and that side. And I don't know if yeah, it's again the same display because it's the same formula actually. Okay, now we got to save this for last because the main connective where the arrow is placed, this is always the last column that you fill in because you need all the other information to be filled in first before you can adjudicate that. So anyway, that means we got to do the tilde next. This tilde, there will be 4 blank spaces below that we're going to fill in. It's going to be the negation of what you see here under the conjunction sign. So for the tilde right, Tanya, it's F followed by 3 T's, T, T, T. So now we've reached the last point. We have to fill in these things, 1, 2, 3, and 4, using the information on the left under this symbol and on the right under this tilde symbol. So what do you see? You see that it's all F's. F because of the right term, F because of this one, F because of this one, and then F again here. So we'll circle this, and now you can tell me what's the status of this sentence that we see between the 3 options, logically true, logically false, logically indeterminate. Yes, it's logically false. And how do we know? Because this main connective column shows all the letter F. That's what logically false sentences show when there is a completed table. What if I change this formula just around slightly so that this is an OR symbol? Okay? Okay, so this part we remember, T, F, 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 T, F, F, F. Since this is the same here, negation flips that, F, T, T, T. Now with the wedge being our main connective, what will be the 4 values written here? Now it says either A and B or not A and B. And since this is not an AND symbol but an OR symbol, what are the 4 truth values now in this case? Just look at the truth table and tell me. 4 T's, correct. And that is because with OR, you only need one of the 2 sides to be true rather than both. So there's no FF, correct. Yeah, this side there's a T, so that's enough. This side there's a T, that's enough. In this case, right side, and on the 4th point within the column, it's the right side again. So this sentence is what? The status of the sentence here, we say is called yeah, logically true. That's right, because all these show the letter T. Now, so if I wanted to give one more example, just to round out this whole discussion here. Well, now that requires a longer truth table. Now, how many rows do I need in this case with 3 sentence letters? I need 8, that's right. Underneath A, the leftmost letter, the first letter in the series, what's the display and the ordering of T's and F's going down in that column of 8? So top half T, bottom half F. That's 4 by 4. And then the next column over, the next subsequent column is just 2 by 2. So that's T, T, F, F, T, T, F, F. And finally here, 3rd column, T, F, T, F, and all of that. Okay, so now we just have to, again, fill in these blank spaces. So underneath A, we have 8 items that follow the same pattern as you see on the left. Under B, we have the 2 by 2 column. And under C, we have that single alternating T and F column. So then, in this case, and there's going to be 8 of those. Let's see who could quickly rattle off these 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 either T or F letters underneath the conjunction sign there. What do you think? So that's our new question to fill in this blanks column. So we should have 2 T's at the top followed by a bunch of F's. That's right. This is because only on the top 2 columns do we have T and T flanking the conjunction symbol. And with an and symbol, it does have to be both true. So since in all other 6 cases, there's at least 1 or 2 F's, all the remainders are false. So now using this wedge, we are going to fill in these 8 spaces. We're going to have to the left this value and to the right that value. So now help me with this disjunction column. There's 8 items in this big column, and what will they show? Arlene, so you're saying it is 3 T's at the top. Then we have F, T, F, T, F. Let's see if that's right. Okay, so true, true. Okay, good. True, false. Again, true. False, true. So yet again, that makes it true because there's just 1 that you need with the or symbol. 1 letter T, either on the left or the right. Now here, we get to the 4th, and then you see F, F. So that makes it false there. In the 5th column, it's true again because of this one on the right. In the 6th column, we have false because false and false on both sides. In the 7th column, true because of the right side, and then finally on the bottom, it's false because of both left and right. So now with this case, we circle the column, and we would say that the sentence is overall what? This type of sentence is what they call a, what's it, the terminology for that? Yes, it's logically indeterminate. Okay, because indeterminate sentences display both T's and F's in the main connective column. Logically true sentences only show T's. Logically false sentences only show F's. Okay, so that's been our review on the topic of how to use truth tables to test whether individual sense is logically true, logically false, or logically indeterminate. So to do the next thing, which is to use truth tables to determine whether a pair of sentences are equivalent or not. How do we do that? Okay, so A and B, B and A. So these are 2 sentences. What we're going to now do, or attempt to do, is to judge by a truth table, are they equivalent or not? Are these logically equivalent sentences or are they not? So up here on the top left, I have to write those 2 sentence letters in the alphabetic order A, B. Underneath A, since there's only 2 letters, there's going to be 4 columns. And on the leftmost, it's top half T, bottom half F. So that's TT, FF, followed by TF, TF. So now, I'm going to draw the sentence letters displayed under each, the truth values displayed under each sentence letter. Okay, when we're judging 2 sentences for equivalence or non-equivalence, we have to have 2 arrows facing down. And the 2 downward arrows are to be placed above the 2 main connectives of the 2 sentences. So for this case, where will our 2 arrows go? Well, it's pretty clear, right? Because there's only 2 connectives even in the 2 sentences. So one of them's here over that conjunction sign, and one of them's here over that conjunction sign. So let's fill in this space. 1, 2, 3, 4. What are those 4 truth values? What are those 4 truth values there in that range? You see it's a conjunction connective, so the rule is the rule for and. Looking at the truth values, you can tell me what's the overall truth value of those conjunctions in the 4 spaces. So true followed by 4 Fs. Sorry, 3 Fs. Correct. Because it's a conjunction, it needs them both to be true. And you only see that here in the top row. Now over here, in this category, or in this column rather, what are those for? Arlene, I guess, yeah, same. So we circle here, and I just got the question, are these 2 sentences logically equivalent or not? That's the question, are they? They are logically equivalent, correct. How do you know? How do you know? What's telling you that they are? What's the visual that you look at that's telling you this? It is equivalent, correct. I'm just making sure that no one's guessing as to why. Why? It's evident here, but I want to say what is the, yeah, well, both sides have T's and F's. Yeah, more though can be said. It's because it's the same value in each row. They don't differ in any of the rows. So like, you're not gonna like look here and see an F and then oops, over here it's T. They match. These 2 vertical displays match, and that's why they're equivalent. If there was even one horizontal row where there was a mismatch of T and F, that would throw it off from being equivalent, and then they would not be equivalent. Okay. So that's no worries with that. Let's just modify it slightly. Now it's these 2 sentences to be compared. A and B versus not the case that B and A. Okay, so what's the main connective of this one here on the right? Now that I've modified the example just a bit, what's the main connective that you can see here to the right? Yeah, it's the tilde. Because the tilde is the thing that's operating on the whole formula. That's why that's that main connective. So again, we're going to fill in the table using these truth value assignments. And you already told me this is TFFF, so that's done. Now over here, underneath B, the display is TFTF. Underneath A, the display is TTFF. And so this part inside is going to look the same as before. But now, what's the range of values that fall underneath this tilde symbol? What this is going to be is the reverse of what's under the conjunction sign. So we'll see the order FTTT. Okay, now, are these 2 sentences logically equivalent or are they not? Are they logically equivalent or do you think no? Yeah, correct. They're not logically equivalent. And why is that? That is because they don't have the same exact truth value in each of the 2 columns. In fact, to the contrary, they have the opposite value in every column. So these are definitely not equivalent. In fact, they're logically contradictory to each other. Are these 2 sentences logically consistent? Different question. They're not equivalent. Are they consistent? Think about it. Are they consistent? Different concept. Consistency. We talked about it as we've already referred to it once in our meeting today, but are those 2 consistent? The same table can be used to judge if they are consistent or no. Someone needs to know this. Someone does know it. Tell me, are they consistent or not? Lily, you're saying no, they're not consistent. Correct, but why? Why not? Well, yes. Who can tell me, please, why is it that these are not consistent sentences? You can't just, so there is no row where the truth tables under the main connective are both true. Correct. There's no single case where they're both true. Look for it. Is it this top row? No. TF. Those are not both true. Is the second row? No, they're not both true. And same with 3 and 4. So you can't see that there's even one row here where they're both true. And that's why it's clear that they're inconsistent with each other. To be consistent, you have to be able to find at least one row where they both have the same value. Now let me think here. Well, what if I added one more sentence to the to this overall set? Because now if we're going to evaluate sets of sentences to see if the set is consistent or not, we can go beyond just a pair. Equivalence is always in terms of pairs. Consistency can be extended to more than just two. So now there are three sentences, and the question is, are they consistent? We have A and B, not B and A, and also A. So underneath A, we have to reproduce this order once again. Yeah, we still don't get the case where they're all consistent. We still don't get the case where they're all consistent because we still don't see any single row where they're all true. What if I added B over there to the right? Would that change anything? TF, TF, no. So anyway, there wasn't a huge amount of fruitfulness to this current point that I made, but I guess what we can see here is that with consistency, it's possible to have more than two sentences involved. Let's do another example where the sentences are consistent. I'll use a double arrow because I think we've kind of gotten in the habit of using that a little more. Actually, here, I want to do it even a little more so that we can get some review on this. So A, then B, and A just in case. So top left, how many letters here? 2, A, B. How many rows on this table? Just quickly, let me know. 4, correct. So underneath A, we have that. Underneath B, we have this. And then we fill it in from there. Okay, so this is the same, and we've done that a couple times, so I'm going to quickly just fill that in for you. T, F, F, F. Okay, now, here, 4 truth values, blank, 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 blank. It's the conditional arrow sign. So if we know the rule for if-then, then we can tell what these 4 truth values should be. So I'm asking, tell me, what are these? 1, 2, 3, 4. Blank, 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 blank. 4 truth values underneath those. Okay, so T, F, T, T. Correct. Because the only condition that the arrow is a false sentence is when you have this specific combination. On the left, and left T, right F, you write F in the middle, but everything else is true, aside from that one possible combination. Now over here, the double arrow, biconditional. 4 blank spaces, and so 4 truth values that we must submit. What are those 4 on this side? Good, Jessica. T, F, F, T. Because the rule for biconditional statements is that they're true in 2 ways. When you have both sides showing F, or when you have both sides showing T. In these other cases, they're not both showing the same letter, and that's why they're false there. So here's my question about this completed truth table. Are those 3 sentences logically consistent or not? Okay, good, Arlene, you're saying yes, they are. Why? How do you know? What is it that you're looking at that's telling you that yes, these are consistent? Because the first row has all truth values, right? So one row, we see everything is true. The top horizontal row. Is there any other row where they're all true? No, but it only needs one. Only one row where they all can be circled horizontally, showing T, T, T is needed, and that means they are consistent. So if there's such a row to circle, you would circle it and write consistent. If that was the question being asked, are these consistent sentences or not? In this case, there is such a row to circle, and that's why we have, and it says consistent. So that's almost all the stuff from the first half of the class. The only remaining topic that I haven't covered so far yet today is how to use truth tables to test for argument being valid or invalid. And also, I guess, how to use these shortened tables. So we can review that a little bit next time. But most of the review next time will consist of reviewing on our derivations and proofs. I received some questions about like that third homework problem. I thought it might be nice to try and display some of the way of answering it. But let me pull it up really quick just so that I can show you it. Okay, so this problem here, it just requires a whole bunch of like disjunction, elimination, and introduction. So what it says is, problem 3, derive this complex disjunction. A or B or C. And what you're given as an assumption is this assumption, which just says that either A or C or B. Okay, so now after that, A or C or B, you need to get to this result. And the only thing you're starting with is this disjunction that's available here. So there's not a whole lot of options at this point. Really what you have to do is start doing disjunction elimination, because this is the only connective that's present in the proof. So disjunction elimination suggests itself. If we're going to do disjunction elimination, we have to assume one of the two disjuncts and then prove a result that we want. Then we move to the other disjunct and prove the same result. So this disjunction has two components. One of them is B, and one of them is A or C on the left. So let's assume the left disjunct first, A or C. Assume for disjunction elimination. Well, we've assumed something, but what we have assumed is itself a disjunction. And therefore, we can't isolate its components unless we do yet another instance of disjunction elimination. So now we have to eliminate this disjunction that's on line 2, starting with A. Okay, so now that A is present, we can use disjunction introduction to start building this big thing. So from line 3, A or B follows by disjunction introduction on 3. Okay? So now on line 5, since we've created A or B, that's what line 4 says, we can disjoin this whole thing to the right of it. So that gives us A or B or C from disjunction introduction of 4. Okay? Since this is the goal, we've finished with the work that started on eliminating this disjunction from the side of A. But we still have to do the same thing from the other C. So there's a small gap in this vertical scope line, and now we're doing part 2 of this disjunction elimination. So we assume C, the other side, the right side. From C, we can introduce this disjunction starting on the right hand. So B or C from disjunction introduction of 6. And then since B or C is present on line 7, we have A or B or C on line 8 from disjunction introduction of 7. Just remember that when you have a formula like B or C, you can disjoin anything to it. And so you can disjoin the whole disjunction on the left here, which says A or B. So we've gotten the same result from A as from C, namely the derived result. That means we close that little subderivation, and what's resulting from it is A or B or C. That's disjunction elimination starting with line 2, then comma 3-5, comma 6-8. Okay, but we're almost done, but not quite, because all of this was just to eliminate this A or C disjunction sign, which itself has a disjunct within it. So that means that we have to now proceed to the right term, which is B. Okay, so B is assumed for disjunction elimination. And then from there, after you have B, line 11 would be B or C. disjunction introduction of 10. Line 12, if I was to continue it over here, would just say A or B or B or C. And that's from disjunction introduction of 11. Finally, then on the 13th line, you'd be done. Because what you're showing now is that A or B or B or C follows from this disjunct and from this disjunct. So we write the result that we want. And that is disjunction elimination, line 1, comma, 2 through 9, comma, 10 through 12. So it's 13 steps to get to the conclusion in this possible proof from the homework set. What you had to do is basically disjoin the complex expression on the left here and then further break it down until each individual letter gives you the sentence needed. Then you would move to B, and B takes fewer steps because there's no need to eliminate a disjunction on this side. You just introduce B or C, and then introduce A or B to it. So in 13 steps there. But all right, guys, that's what we had time for today's meeting. I'm going to stop the screen share and close this Zoom meeting, and then I'll see you guys back on Wednesday. Thanks, as usual, for all of your help and hard work. And I'll be in touch with you guys through email and also just through class announcements. So see you back on Wednesday, and have a good day and a good start to your week, everybody. Thanks again. I'm closing this one. And then I'm closing this one. So thanks again, everyone, and I will see you soon. Take care.